Alrighty, problem 2. The figure above shows the polar curves r equals f of theta and r equals g of theta for theta between 0 and pi over 2. Let r be the region in the first quadrant bounded by the curve r and the x-axis. Let s be the region in the first quadrant bounded by the curve r equals f of theta and the curve r equals g of theta and the x-axis. So first of all, part A asks us to find the area of r, and if you recall from when we have been dealing with polar, the formula for area is the integral of 1/2 r squared d theta, and we'll put our limits on there as well. So if we want to find the area of r, it's just this area right here. They did tell me where it was going from, so the area is going to equal 0 to pi over 2. It'll be 1/2 times r. Well, in this case, they told me that r was being bound by f of theta, so f of theta is our r squared d theta, and then f of theta, obviously when you plug it in your calculator, is going to be this formula right here. So if you plug that in, you should get 0.648. Okay, this part was worth 2 points. We're going to get 1 point for the integral setup and then 1 point for the correct answer. Okay, part B, the ray theta equals k, where k is somewhere between pi over 2, divides S into two regions of equal area. Write, but do not solve, an equation involving one or more integrals whose solution gives the value of k. So first of all, S is this region right here. And what they're wanting us to do is draw a ray somewhere. I'm not sure exactly where it's going to, but what we want this ray to do is split region S into two spaces of equal area. So the first thing that I know that I would like to do is we need to find that full area before we could even split it in half. So the full area is going to be just like what we did on the previous problem, 0 to pi over 2. And to get the region in between, we're going to have to subtract the outer area minus the inner area. So the outer area is going to be 1/2 g of theta squared, and then we're going to subtract 1/2 f of theta squared. So that will be the full area, and d theta, of course. All right, so that was the full area, and now we want k to split this in half. So we only want half of this, and we want it to figure out where, am I going to have to go from where to where? I'm going to have to go from 0 to k this time instead of 0 to pi over 2. My formula inside is going to be the same because it's still, I just want half of that area. Minus. I guess I'm putting too many parentheses here. I'm going a little parenthesis crazy, sorry. There we go. Okay, so that's going to be the setup. Now there's many different ways that you can write this setup, but this is generally, we just need two expressions that do equal each other, something like that, and it didn't tell us that we had to solve it, we're just writing it. So let's see how we would get points for this one. We'd get 1 point for this integral expression. So if somewhere you knew to do 1/2 g squared minus f squared, we're going to get +1 for that. Okay, again, there's many different ways of writing that. I could have written that as 1/2 g of theta squared minus f of theta squared. I could have just factored out a 1/2. So lots of different ways I could do that. And then I'm going to get 1 point for having the equation. So if you have an equation that's equivalent, then you're going to get a point. If you have an equation and want me to check it, I certainly can do that. Okay, for part C, for each theta between 0 and pi over 2, let w theta be the distance between the points with polar coordinates f of theta, comma theta, and g of theta, comma theta. Write an expression for w theta, and then find w sub a, which is the average value of w theta over the interval. So we're going to find a distance, and then we're going to find the average value. So finding a distance, first thing, I'm just going to put this into point. Just notice they both have y values of theta, so that would be like finding the distance between 5,3 and 8,3. Okay, if the y values are both the same, all we have to do to get the distance between those two is just subtract the x's. So that's what we're going to do here. We're just going to subtract the x's to get the distance. So to get that distance, so we're going to have w theta is the distance. It's simply just going to be g of theta minus f of theta. And I did g of theta first because it comes on top. So that is it. That's all that it is. Okay, so that was the integral. And then it says to find the average value of this. So if I want to find the average value of a function, if you recall, it's just 1 over b minus a times the integral from a to b of the function. So we're going to do, for this part, we're going to do 1 over b minus a, which is going to be 1 over pi over 2 minus 0 of the integral from 0 to pi over 2 of my function, and my function is w of theta, which in this case happens to be g of theta minus f of theta. Okay. From here, they actually ask me to find that, so if I type that all in my calculator, I should end up getting 0.485. All right, so this whole problem was worth 3 points. If you got the expression written down correctly, you are going to get 1. If you properly have an integral right here, so you took the integral from 0 to 2 of w, you got a point, and then if you found the right answer of 0.485, you got your 3rd point on that one. Okay, part D, using the information from part C, find the value of theta for which w of theta is equal to w sub a. Is the function increasing or decreasing at that value? So again, two-parter, we're going to find the value and then find out is the function increasing or decreasing. Okay, we're going to take w of theta and we're going to set it equal to the average, which we found in the last part was 0.485. Okay, and then from here, we are going to w of theta, if you recall, was g of theta minus f of theta equals 0.485. Okay, 2 ways. You're using your calculator, so don't do too much math here. We could graph this in as y1, graph this in as y2, and look for the point of intersection, or I could move everything to the left side and then use the 0 feature of my calculator. Either one of those will give you the right answer, but when I do this, we will get theta equals 0.518, okay? Then it says, is w theta increasing or decreasing? Well, if I want to know if a function is increasing or decreasing, I need to find its derivative. So I need to find w prime of 0.518, which is going to equal g prime of 0.518 minus f prime of 0.518. And we can use Math 9 on that because we definitely don't want to do the work ourselves. So if Math 9 for each of those, if you subtract those, you're going to get negative 0.581. And then it asks, is the function increasing or decreasing? Well, w prime was negative, so I'm going to say w theta is decreasing. And I will say that it is because w prime of 0.518 is a number that is less than 0. Okay, so our points for that one. If you solved this formula right here, you're going to get a point. And then if you correctly said that w was decreasing and y, you got your other point on that one.